At D-Climate, I'm going to skip a lot of the background of exactly who we are and what we do on a broader level. Carbon is one of a number of initiatives that we take, but at a very high level, we are a decentralized marketplace and network for climate data that is solving issues with climate data access that will help enable better analytics, both in the carbon space as well as other parts of ReFi in general. So we really look at our mission as providing core infrastructure for data-driven climate products. So as it relates to carbon, the global carbon market has mostly been stifled by centralized registries that don't operate fast enough to really bring on the scale of carbon needed to meet the supply and demand mismatch within this market. So currently, NGOs have been doing good work, well-meaning work, but they just can't bring enough supply on to meet all the needs of the market participants as more and more countries and corporations try to reach carbon neutral goals by 2030, 2040, 2050. There's various kind of ambitious goals there, and offsets for us are a great way to proceed, but only one of many different ways to be impactful in terms of climate action. So for us, going back to what I said regarding data, for us, we look at these problems as ones that are potentially solved through better access to data and ones that should be solved in a data-driven manner so that we can have concrete metrics to both track progress and track areas where more work is needed. So what we developed in-house is a satellite imaging based system that uses satellite images provided by NASA, European Space Agency, and others, along with computer vision algorithms to essentially estimate the amount of carbon within a forest. And so it's a really cool mix of doing a lot of neat stuff with computer vision as well as with AI models. And so one of the things we like about this process is that not only does it allow us to do verification very quickly, which is one of the issues with the traditional registries that can take 5 to 10 years even to verify a piece of land, but it also allows us to verify areas of the world that are too difficult to do manually, namely like deep old growth tropical rainforest, which also sequesters a large amount of carbon. And we believe it's necessary to preserve and verify these lands because while reforestation efforts are very important, in our opinion, prevented deforestation, in our opinion and analysis, prevented deforestation is a very impactful way to spur climate action. And it's great to preserve the natural assets that we have. So our model is actually able to meet the European Space Agency's kind of holy grail for biomass estimation. So we have a rough error of 30 to 50 tons of carbon per hectare, and that's within the 25 to 35% relative error range. I think if we can get it down to 20, it'll be even better. Because it's all data driven, as satellite images improve due to new hardware, or as more ground truth data is available thanks to the work of a lot of other projects within the ReFi space, we can continue to improve these models. And so that kind of leads me into the second part, which is the importance of ground truth altogether. So right now we use European Space Agency's above ground biomass maps, but nobody really has a good read on ground truth. So it's been great listening into what some of the other projects are doing, because we can help not only bring that data to a marketplace so other people can acquire it, but we can use that data to make these models better and get better estimation of how much carbon is on the ground. And so this is just a neat little photo showing that as we continue to retrain the models, we are getting better and better error rates, and hopefully we can get that down from 30 to 50 tons to maybe even 20 to 30 tons per hectare. So at T-Climate, we look at a lot of what we're building as blockchain agnostic. So our main kind of API is used by insurance companies, hedge funds, kind of your traditional Web 2.0 companies, because we package it as a REST API, even though it's built all on decentralized infrastructure. In the case of the carbon product, what we can do is we can we can tokenize carbon on various blockchains. So here we use Celo and Polygon as an example. We've been working a lot on the Polygon side, just due to kind of a nice tech stack, as well as some of the work that was being done by Toucan and other projects. We want to make it easily feed into different ingestion engines. We use satellite images to get the above ground biomass, as I mentioned earlier, and then we use a chain link node to essentially create tiles around it. And the reason this is important is, instead of acquiring land or trying to buy forest, we think that by tokenizing the carbon and leaving the land alone in the hands of countries, we can avoid messy land rights. But more importantly, we can just bring a larger scale of carbon to the market. And so here's a little teaser of what our CO 2.0 portal will look like. This is powered by our MRV models. And so we want to tokenize forests, and for that we enter in agreements with countries for exclusivity rights that avoids the double spend problem. And then you have these nifty little NFTs that you can buy, and what the NFT holds is a certain amount of carbon for a piece of forest. And so now what's exciting is that for a corporation, an individual, or a DAO looking to offset their carbon footprint, instead of buying a traditional offset, which you can certainly still do, we look at this solution as complementary to the standard Vera or gold standard offsets, because we are bringing on a different source of supply. You now have a digital asset. And we all know, all the nifty little things going on in the DeFi world. And so now you have a digital asset that allows you to really capture upside in carbon prices. We can pool together these NFTs to create interesting derivatives. And really, I like thinking about this as this idea of creating kind of an own DeFi economy around carbon, and turning carbon from something kind of nebulous where you say, I bought an offset and it's covering this much carbon usage for the next 10 years, into I own this much amount of carbon and it's tied to an actual real world forest. On the flip side, how we were able to enter into these agreements is that countries get cash flow payments. So it becomes their natural asset essentially becomes a fixed income instrument where they get paid over a period of, let's say, 10 years, regular cash flows. The satellite continues to monitor. If there's deforestation, those payments get slashed. And so MRV really is at the core of making this solution work. And so once you have this cash flow system, you basically incentivize long-term preservation. So countries can now think about, okay, well, not only do we want to preserve forests today, but how do we make this even more valuable 10 years from now when we remint our assets, right? And so we refer to this.
I want to give you a heads up on the time.
Yeah.
You're a bit over, but yeah.
We refer to this model as pay to preserve, and this idea that we can monetize natural assets without destroying them. And so this little icon is a teaser for our MRV solution. Robbie wants me to hold off on naming names and describing all of it. So stay tuned. Later this year, ideally by fall, we'll announce everything and have a nifty little UI. So any of the people doing work in this space can utilize the tech to get carbon estimates, and hopefully we can continue to provide great core infrastructure for that space. So we have this question slide. I know there's not really any time for questions, but if anyone has any, feel free to DM me either on LinkedIn or Twitter, and would be happy to discuss in more detail.